Hey, welcome back everyone to the another live session. Of course, this is not live, but we'll be uploading this video later, and you're watching a recorded one. So don't put your questions live. But of course, if you have any questions, put that question in the comment section so that we can take that in the next episode. Okay, now today we are talking about something interesting. Last week we talked about Docker, and this time we will be talking about Kubernetes. Of course, we are going up, right? And then soon we'll reach the cloud. Or not that one, but the cloud in technology. And for that, we have Ranga with us. And let's welcome Ranga to the screen. Hey, hi, Ranga. Another
Hi,
weekend.
Naveen. Absolutely. It's still the weekday, I would say, Friday for us. I'm
No, the
waiting for
thing
the
is,
weekend.
yeah, people normally treat Friday as what do you say, pre-weekend
Okay.
day.
Makes
Yeah, so
sense.
they,
Absolutely. Take
yeah,
an early Friday afternoon.
yeah, something that way. And then they hate Sunday as usual because the next day is Monday. Great. So all excited to talk about Kubernetes today, Ranga?
Absolutely. Kubernetes is such a wonderful thing. And yeah, and also, like if you look at the technology world, I think if you list the top 5 technologies, I think Kubernetes will be one among them. So that's
Oh,
it's growing like anything.
awesome. In fact, I have an idea in mind to launch a new video, the top five technologies. So this time I will include Kubernetes in that.
Oh, sure. Must. Docker, Kubernetes, cloud.
Yeah.
These 3 must be there.
Awesome. Awesome. So the first question for you, Ranga, I mean, of course, we are talking about Kubernetes here. And then to be very honest, I'm not sure how many of you they know this, but I have never worked on Kubernetes. I have used Docker. I use some services which uses Kubernetes behind the scene, but actively, I've never configured a Kubernetes cluster or never worked on that. So a question to you, because of course I have not worked it practically. So question is, why do we need Kubernetes when we have Docker?
Right, right. So when you talk about Docker, Docker represents one single container image, right? So whenever we want to, we execute a Docker command, we are running one container image. Or you can execute the same command multiple times to run 10 container images, for example. And let's say we are talking about microservices architecture, right? So microservices architecture, you have 10, 15, 100, 1,000 microservices. You don't want to individually run and manage these microservices. I have a picture also drawn, Naveen, about this, right? So whenever we talk about microservices architecture, what we are talking about is multiple different architectures, right? Multiple different microservices which are talking to each other. And there are a number of requirements for these microservices, right? So if you look at these microservices, this microservice might have 3 instances, this microservice might have 4 instances, this microservice might have 100 instances. So each microservices will have their own specific needs. Based on the number of instances, you would want to be able to load balance. So one of the primary requirements that you would see is when I have multiple things, I would want to be able to load balance between the active instances. If I have 10 microservices instances, for example, then I would want to first be able to load balance between them. Second thing is something called auto scaling, right? So you'd want to be able to identify the load on the microservices and increase the number of instances of the containers based on the load. If I have 10,000 requests, maybe I need 10 containers. If I have 100,000 requests, maybe I need 100 containers. You don't want to manually keep increasing, decreasing things. You want to be able to do that automatically. And in addition, if you look at, there are a number of common features that are needed for these microservices, right? So each of these microservices will have configuration, and this configuration varies from one environment to another environment. So you have a need for something called centralized configuration. And if I keep going on, there are a lot of other requirements whenever we talk about microservices architectures. You would want to be able to release them in a very, very easy way. Number 5, I would also want to touch about self-healing. So if you look at these microservices, let's say this instance goes down, right? You don't want to manually stop that and replace it with another instance. You should have something automated in place that can discover that this is down and replace it with another active instance. And add on to this, if I'm running a microservices architecture in production, imagine that if there's a problem, you want to be able to debug it, right? So you'd need some kind of logs. You need logs for all these microservices in a centralized place. You'd want also tracing. If a request is going in, you'd want to be able to identify, hey, Where did this request go through? Why am I having a problem? So you also have a lot of observability needs also when it comes to microservices architectures. If you look at last few years, when the microservice architecture came in, the first solution that we really went to was Spring Cloud, right? If you looked at microservices architecture, Spring Cloud was one of the most popular ones, which was made use of. Spring Cloud provided a number of these features. If you wanted a load balancer, you can use Ribbon. If you wanted like auto scaling, it had features. If you want centralized configuration, there was Spring Cloud Config Server. So there were individual solutions for each of these problems, but enterprises start feeling the pinch of actually having these separate different solutions for different problems related to microservices. I think that's where the role of the container orchestration solution comes into picture. With Kubernetes, you can actually get all the features that I've talked about, right? I've been talking for almost 5 minutes now, and I've talked about a number of different features. All these features are provided by Kubernetes, and that's why Kubernetes is becoming really, really popular.
Awesome. Now, one thing you talked about, one word, which was, of course, we have, I guess we have talked about that word in the last session as well, when we talked about Docker, which is container orchestration. So what exactly it means when you use that term?
Exactly. So what we mean is, like, the basic terminology is container and orchestration, right? So container is nothing but a running version of a Docker image, right? So you are running an application somewhere using containers. That's a running container. When you have a lot of these containers, right? Whenever we're talking about microservices architecture, we are talking about like maybe 10, 15 microservices and maybe multiple containers for each of these microservices. So we are talking about hundreds or thousands of containers. So what we would want to be able to identify is which container is working well, which container needs to be replaced, how many requests are coming in, should I increase the number of containers, should I decrease the number of containers. So you can see that there is a lot of play which is involved. Like there is a lot of, like, orchestration is something like a dance, right? Typically orchestration is used when, like, you have a dance troupe and everybody should be properly orchestrated. Similar to that, over here we are orchestrating containers. Like Kubernetes is basically the container orchestrator, which says, hey, there are more requests coming in. I would need to launch a new version of this microservice. I would need a new instance. This microservice instance is not responding. I need to remove it out. There are like new instances added in. I would need to add them to the load balancer, right? So there are a lot of orchestration kind of things which are going on in the background with respect to containers. And that's why this group of tools, right? So you have Kubernetes. You also have something called Docker Swarm. These are called, like there is something called Mesos, which was used earlier, Mesosphere. These are all do this, right? They actually orchestrate microservices or containers belonging to multiple microservices. That's why this word container orchestration became popular.
Awesome. And now I can remember in this last session as well, we have talked a bit about it regarding Docker Swarm. Awesome.
Right.
So now when we are talking about these two technologies, Docker and Kubernetes, and then most of the terms are similar, right? They deal with containers, they deal with orchestration. So how do we relate Docker with Kubernetes?
Absolutely. So if I have a microservice, I would want to use Docker to build an image of the microservice. And what I'm running is a Docker container, right? So individual things are handled by Docker. So each of the container is a Docker container. And the runtime, which is used typically, is a container runtime. Docker has a runtime of its own. So whenever you'd want to run a Docker image, you need a runtime, which is also a Docker runtime. However, on top of it is where Kubernetes or the container orchestration comes into picture. So when we are talking about one container, it's Docker. When we are talking about managing hundreds of containers belonging to different microservices, that's container orchestration, that's Kubernetes. So the way I see it is you need to learn both Docker and Kubernetes, right? So Docker is the fundamental building block, and only then you would be able to go to Kubernetes. If I have to take a similar example, probably Java is the programming language, and you use Spring Boot. To use Spring Boot, you would need to know Java, right? Similar to that, Kubernetes is the container orchestration, Docker is container. However, there are alternatives to Docker, right? Kubernetes does not only work with Docker containers. Kubernetes also works with other containers and other container runtimes as well. So Docker is just an example of a container format and a container runtime. Kubernetes can work with other container runtimes and other formats as well. And that's why you would see certain people would say Kubernetes is not using Docker and things like that. But as a learner, learners don't need to worry about it. That's well beyond them. They should not worry about it. Learn Docker, learn Kubernetes, and they would be able to easily adjust to whatever Kubernetes uses.
Right. For beginners, it makes sense, right? So first learn Docker, then learn Kubernetes. Of course, when you start working on a big project, every company have their own way of working. So they might be using some different container runtime. Now that makes sense. Now coming back to when you mentioned about Java, of course, we are Java developers and we love to work on different Java technology. And then in the last Docker session, we have seen how do we run a Java application on Docker, right? So we talked about Docker desktop and stuff. So how do we deploy a Java application in Kubernetes or in general any application?
Sure. Let's go to the picture. Probably, I mean, last week we talked about how we build a Docker image and we push it to a container repository, right? So somebody commits a piece of code into a Git repository, a continuous integration cycle kicks in, maybe you'd run unit tests, do a lot of things, and everything is fine. Then you would build an image and you would push it to a container registry, right? There are multiple container registries which are available in different clouds. And this can be done for different microservices. You would have different source control repositories for different microservices. So you would have an image. The great thing about Docker is the fact that it does not matter what code is present in here. Is it Java? Is it Python? It can be Node.js. It does not really matter. At the end, what you have are container images for the microservices. The technology which is used to build that container image does not really matter. Once you have a container image, what you can do is go to Kubernetes, right? So that's where with Kubernetes, if you look at it, the first step, whenever you want to actually deploy something to Kubernetes, is you need to create a cluster. That's the first thing that you need to have. So the cluster is nothing but a set of hardware or set of virtual machines where you'd want to deploy these applications to. In Kubernetes terminology, these are called nodes. So each of these things that you see in here are nothing but virtual machines, like different machines where you can run your applications on. And Kubernetes categorizes them as nodes. So each of these machines is called a node. And typically, right, whenever we have hundreds of worker nodes, we need a manager, right? We need a manager to allocate workload to it, right? So this somebody who says, okay, this worker node, you run this container. This worker node, run this microservice. So that's where the master nodes come into picture. So the master nodes are the ones which control the flow. So the master node is the one which says, once I give it a container image, it says, okay, there is space on this worker node. So go and, hey, worker node, go ahead and run this specific container and things like that. So the first thing is to create a cluster. Once you have a cluster, you can actually create a container image for your microservice, right? So whichever microservice that you would want to deploy, whether it's a Java microservice, a Python microservice, whichever one you would want to deploy, you would want to create an image for it. So that's the second step. Once you have a container image and once you have a cluster, you can go and tell the container orchestrator framework. There are a number of ways you can execute commands. One of the popular ways is to use kubectl. Kubectl, or it's also called kubectl. It's a short form. Just like you can run Docker commands, you can run Kubernetes commands using kubectl. And with kubectl, you can say, I would want to run the container image, which is for microservice 1 and v1. So what it does is it would go to the container registry, it would fetch the container image, and it would run it on one of these worker nodes. So at a high level, I would say the three steps are: first, create a cluster, create an image, and then run that specific image on a specific cluster. Again, the important thing to note here is cluster would be created only once, right? You would create a cluster once, and then running the whole thing would be done multiple times based on your specific needs.
Great. Now this makes sense. Of course, there are so many new terms to to look at, Ranga. Great. Yeah. And then, every time we talk about Kubernetes, you're talking about microservices, right? In fact, in the previous question also, you mentioned multiple times microservices. And now it makes much more sense. Whenever you have a microservices architecture, it's better to use Kubernetes, right? So somewhere Kubernetes simplifies the use of microservices and deployment of microservices. Can you just give some tips? I mean, some points where it helps to deploy
Absolutely.
microservices.
Absolutely, right? So whenever we are looking at microservices architectures, these microservices might be built in different languages. I might be using Java to build 10 microservices. I might be building 5 microservices in Python, right? So there are a variety of languages that can be used to build these microservices. So the way you deploy a Java microservice can be different from the way you deploy a Python microservice. And also, like if you look at solving production problems, right? The data you would need to solve a production problem, the way you get logs from a Python application might be different from that of a Java application or any other type of application, right? So once you have a container orchestrator and you're making use of containers, all these things become standardized. All these becomes a standard, right? So once you have a container image, it does not matter what's inside the container image. The way you deploy it is the same. The way you get metrics out of it is the same. The way you get logs out of it is the same. It does not matter whether it's a Python application, Java application. If you have a Python application, just write it to standard out. If you have a Java application, just write it to standard out. Once you have a container image, the logs will be automatically streamed out and you'll be able to track them. So it helps you to standardize everything in your development process, right? Typically, whenever we talk about people only think about the first step in the development process, which is to write code, right? But there are a lot of things. You write code, first build something, deploy it. It's not just one environment. You'd want to take it to multiple environments, dev, QA, stage, production. And in production, you would need observability. You would need to look at logs, metrics. You need to look at everything that comes out so that you'd be able to solve problems in production, right? So what happens is the entire life cycle would be simplified when you go for containers. And when we talk about microservices, there are tons of containers. And that's where Kubernetes helps you with not only standardizing everything, but also offers some of the features that are needed for microservices architectures. One feature which I would want to highlight is like earlier when we talked about Spring Cloud, we used to have something called Eureka. Eureka helps you to do service discovery. A microservice wants to find out where another microservice is present. You don't want to hard code the URLs, right? If you hard code the URLs, if the URL of the other microservice changes, you need to change the other microservice as well. And that's where you go for service registry. So Kubernetes provides you a service registry by default. So anything that you deploy to Kubernetes, you can discover it very, very easily using the Kubernetes discovery. Another feature which we talk about when it comes to microservices is centralized configuration, right? There's a lot of configuration which is attached. And with Kubernetes, it's easy. You have something called config maps. You have something called secrets, which help you to do centralized configuration. So almost all the features that you would typically look at when it comes to microservices architecture are provided by default by Kubernetes. And that's where there's a lot of advantage that enterprises see in using Kubernetes for microservices architectures.
Awesome. Now things are making sense. So mostly it is for microservices and things are much more simpler now, right? Great.
Absolutely.
And then when we talk about Kubernetes, in the last image when you shared, you talked about clusters, right? And you talked about different nodes. So
right.
Are all the nodes are similar, or do we have a hierarchical structure there?
Right. So when we talk about a Kubernetes cluster, you have two kinds of nodes, right? Master nodes and worker nodes. So the master nodes are the one which are managing the worker nodes. So let's say I would want to have 10 instances of a microservice. What I would need to tell is execute a command, a kubectl. I would want 10 instances of this specific microservice. The command goes to the master node. And the master node is the one which finds out, hey, which worker node has space, right? It needs to first find out, okay, which one has the vacant space to fit that specific microservice containers in. And then it would deploy those things to the specific nodes. So if you look at the category, then master nodes control everything. They are like the managers. The worker nodes is where all the things run. So worker nodes is the place where your containers actually run. Your microservices would be running on the worker nodes.
Okay. Yeah, you have talked about it. There was some mess up in my mind. Awesome. Great. Now, coming back to Kubernetes, I was able to read and watch some videos regarding Kubernetes last month, and then there was one of the term. In fact, the video which we talked about last time, there's a documentary on this channel called Honeypot regarding Kubernetes, and then the word pod was used a lot of time. So basically, there are some
Yeah.
important concepts in Kubernetes which we can talk about. So one of them is pod, service, replica set. If you can just talk about those important concepts.
Yeah, I think that's one of the biggest challenges to understand when it comes to Kubernetes, right? Understanding the fundamental concepts of Kubernetes, pods, replica set, service, and deployment. These are the four important concepts that a lot of people struggle with, right? So let's probably go to the diagram that I have, and let's quickly look at what are the different things which are related to different concepts which are related to Kubernetes, right? So if you look at this specific diagram, what we have in here is a single worker node. I'm assuming that the entire cluster just has one node, just to simplify things, right? If you have multiple worker nodes, then it becomes complex. So let's take a very, very simple example where I just have one worker node. Let's say it's very, very big worker node, and I can run as a lot of containers on it. Like let's say I would want to run 1,000 containers on it, I will be able to do that as well. So, and let's say I have two different microservices, right? Let's call these microservices M1 and M2. So we have two different microservices that we would want to run. So each of these microservices is represented by a deployment. So M1, M2 is what is called a deployment. So M1 will have a deployment and M2 would have a deployment. Whatever you are seeing in here are what are called the pods, right? So right now, how many pods do I have? I have 8 pods in here. So I have 8 pods. However, these pods belong to two different microservices. Over here, I indicated the specific microservice which a pod belongs to by the color. So the orange color in here indicates that it's microservice 2. So whenever you see an orange color, it's microservice 2. And whenever you see a blue color in here, it's microservice 1. So what we have in here are pods belonging to two different microservices. So I have 4 pods for microservice 1 and I have 4 pods for microservice 2. And how many deployments do we have? We have only 2 deployments. One deployment for microservice 1 and microservice 2, right? So a deployment is nothing but something which correlates with a microservice, right? So each microservice will have a deployment, and a pod is nothing but a running version of a container, right? So I have 10 instances for this microservice, and let's say I have 15 instances for this microservice, then I'll have 10 plus 15, 25 pods, right? So that's simple, right? Pod and deployment are typically easy to understand. A pod directly relates to an application or a microservice, and a pod is nothing but a specific running version of a microservice, right? And service is something which you would use to expose it to the outside world, right? So if I would want to, let's say, expose a specific deployment to the outside world, to, like, let's say I would want to be able to send a HTTP request or a REST API request to this specific deployment, what I would need to do is I would need to create a service. So pod is a running instance, deployment maps to a specific microservice. Service is something which is used to expose the deployment to the outside world. If you want to execute some URL and access the specific code which is running in the container, you would need a service, right? So those 3 concepts are typically easy to understand. The concept which is little difficult to understand, little tricky in here, is the concept of a replica set, right? A lot of people struggle with it because it's a little different. If you have microservice 1 and microservice 2, each of these microservices can also have multiple versions, right? So I might be having a V1 for this microservice and a V2 for this microservice. So there might be multiple versions of a specific microservice running in production. Like, for example, let's say I'm doing a test. What I might want to do is to have V1 deployed on 100 instances, but V2 deployed on only 10 instances, right? So those kind of situations are where replica sets are really, really useful. Replica set represents a specific version of a microservice. So over here, if you look at it, for microservice 1, I indicated the version using this violet color in here. So we have, for microservice 1, we have 4 things of the same version. However, if you look at microservice 2, you have 2 colors, yellow and green. So we have 2 versions of these microservices instances running, right? So the V1 is indicated by yellow in here, V2 is indicated by green in here. So we have 2 instances of V1 and 2 instances of V2. And replica set is the one which represents each of these versions. So in total, if you look at it, we have M1, microservice 1, we have one version, V1. Let's call it V1. And microservice 2, we have two versions, V1 and V2. So we have total of 3 replica sets. So a replica set is related to a specific version of a microservice. So deployment is related to the microservice. The microservice can have multiple versions. For each of those is where you would want to have replica sets. So it's kind of tricky. It's like very, very tricky to understand. And that's why I thought having a diagram here really, really helps. Naveen, was that understandable?
Yeah, much better, much better. I mean, of course, when you explain something and then if you have a diagram with that, it's always simple to understand. But of course, it will take some time for my brain to get adjusted to all these words and concepts.
Absolutely. So the way I think about it is very, very simple, right? A deployment maps to a microservice. A replica set maps to a specific version of a microservice. A pod maps to running instance. Like if I have 10 instances of microservices running, then pods would be 10. And service is to expose these to the outside world. Like this might be little struggle, like little bit difficult to understand for beginners. But once you have a good grasp of it, you will see the power of Kubernetes. The reason why Kubernetes has a concept called replica set is because a lot of times when we are talking about microservices architectures, you need flexible releases, right? I don't want just one version of a microservice running. If I have 100 versions of microservice, maybe I would want 95 to be one version, 5 to be other version, so that I can test it whenever I have a new release, let's say. This will also help me to have different release strategies. So let's say I'm making a new release. Let's say I have 100 instances live of a microservice. I can first say 5 instances I would want to test with new one. Once 5 instances are all successfully tested, I can say I would want to add another 10 instances. So it gives you a lot of flexibility in how you release software. Replica sets are more related to releasing a specific software or a specific microservice, new version of it to production.
Awesome. Makes sense. So, after this, I'm quite excited to explore more on Kubernetes now. So maybe, once I come back from my vacation, or not exactly a vacation, but a business tour, I will start learning Kubernetes a bit. I mean, I have read about it, but I just want to implement something with my, getting a labs environment will be helpful.
Absolutely.
Cool.
Absolutely. I think if you are planning to start playing with Kubernetes, maybe, if you have a powerful laptop, you can install Minikube on your local machine. Or if you have a free tier Google Cloud account, you can create Google Kubernetes engine clusters as well. So those two options, like you can use cloud to create Kubernetes as well.
Okay. You mentioned about Minikube, right? Which is Minikube. Okay.
Absolutely. Cool. So that's something which you can install and that helps you to run Kubernetes on your local machine. But whenever we're talking about Kubernetes, we're talking about multiple nodes and also deploying multiple containers. So it can become a challenge. The kind of resource, the kind of power your laptop needs to have is little high.
Okay. In that case, I have a desktop, which is a gaming desktop, so it should support.
Yeah, that should be more than sufficient, I guess.
Right. Great. So those are the basics of Kubernetes. I have a few more questions, Ranga, but then we can divide into 2 parts. Today we have talked about the basics. Maybe I have some more questions. We can take it next week. But that was a wonderful talk about Kubernetes, Ranga. So instead of wasting my 8 to 9 hours learning about basic concepts, we did that in half an hour. What more do you want on Friday?
Yeah, glad to be able to do that, Naveen. Also, like for the viewers, if you have any questions related to Kubernetes, do post them in the comments and we will actually take them up and we will probably discuss them in the next week's session.
Yes, and that's when we have 2 episodes, it's very helpful. In fact, everyone, if you can post question on any video and we'll pick up it for you on this series at least, because this is live, not live for the YouTube, but we are picking your questions from the last video. Great. So thank you so much, Ranga, for this interesting talk on Kubernetes. We'll connect next week on part 2 of Kubernetes because it's a big topic, right? Thank you so much, Ranga.
Thanks a lot, Naveen.
And everyone, make sure you subscribe in 28 minutes. You will find the link in the description and also the same channel because the next episode will be coming on this channel. Right?
Absolutely.
Bye-bye, everyone.
Okay, go ahead. Have fun, guys. See you.